Okay, I see a quadratic equation. I know it's quadratic because it's an x squared and there's a linear term, so I don't have to, and they're telling me to use, they aren't telling me how to solve it. I'm telling you want to do factoring, okay, for this exercise set. So let's do this problem here. Let's see, write this in negative 3x squared. That negative 3x squared is problematic, isn't it? Oops. Here, I undid that. Here, let me undo that. Minus 13x plus 10 equals 0. So now here's the nice trick about these. Negative 1 is a common factor. I can divide anything by negative 1 or just about anything by negative 1. And that's going to be, what that's going to do is that's going to turn that to a positive 3x squared, which is a lot easier to deal with. But I can't take any other number out. I mean, 3 and 13 and 10 are relatively prime, we say. We can't divide them by a number, but I can divide it by negative 1. And then what happens when I divide 0 by negative 1? It disappears, right? So we don't even have to worry about that negative. What it does with these parabolas is instead of opening up, it opens down. Still crosses the x-axis at the same place. Don't worry about that right now. So we've got 3x squared plus 13x minus 10. Remember I divided by negative 1. And no GCF, so I'm kind of stuck there. Well, other than the negative 1. So we'll write 3, we'll write 13, we'll write negative 10. And we have to multiply 3 times negative 10 and get negative 30. So what are the factors of negative 30? They will subtract to give me 13. And I know they have to subtract because I got to get a negative. One of these has to be positive, one has to be negative. Do you see? Well, let's see, 1 and 30, and one of those has to be negative. Actually, we want the smaller one to be negative because I need I need a positive number left over after I subtract them. Then I could do negative 2 and 15, and I hope you see that is the answer, right? Negative 3 and 10, because 15 minus 2 is 13, so that's the combination we want. Boy, no factor tree needed here. Easy peasy question. So negative 2 and 15 are what we want. Now we're going to substitute in our values into our box here. 3x squared and negative 10. And then we'll stick the negative 2x here. And the 15x here. And let's see, what can I factor out? I can factor out a negative 2 here. Remember, if this first thing is negative, we want to make the thing we're taking out negative. So negative 2. And up here, we can factor out a 3x. And then going this way, I can only take out an x. And then going this way, I can take out a 5x. And notice the negative is down, not next to the box we're taking out, so we'll want to take out a positive. And if we had taken out a negative anyways, a negative times a negative is a positive, wouldn't give me the negative 10. So I'm going to take out a positive 5. So then I'm going to get, let's see if we can move this up. Oh, good. And so this factors to 3x minus 2 and x minus 15, or x minus 5, sorry about that. Or is it x plus 5? I can't read my own writing here. So let's do some erasing. X plus 5, and that checks, right? I'm questioning myself. I'm going to check. 3x squared, 3x times 5 is 15x. I know I'm not doing the box. I hope you're getting to the point where you don't need it, but if you still do, you could do it to double check my work. Yeah, 13x. Yeah, that's okay. So we're good. I did that correctly. I don't have to do anything else. That's what you want to do when you're factoring. Eventually, you won't need this template, and you'll be able to do this in your head. At least that's the goal. Those are equal to 0. So then we need to say, when does 3x minus 2 equal 0? When does x plus 5 equal to 0? I'll add 2, divide by 3, so x equals 2/3, and I'll just subtract 5 here. And so those are the two answers. 5 2/3 and -5. Let's see. So what's the listing? So what I would do to make my open math happy, I would do the -5 first, comma, then 2 divided by 3. That should take that.